All right, we are doing 2-8 part 2 notes today, and we're doing absolute value inequalities. Now, first things first, anytime you have the absolute value, you have to have it isolated. So the first one is isolated for us, and it says the absolute value of x is greater than or equal to 7. So if you think about this, and I just said absolute value of x equals 7, what you could take the absolute value of is 7 or what? -7. Isn't that the rule? So if I had said the absolute value of x just equals 7, you would tell me x could be 7 or x could be what? -7. Because the absolute value of 7 is 7. Absolute value of -7 is 7. So same idea, but here's the deal. What's the inequality symbol here? What symbol is this? Greater than or equal to. Okay. You know how we say greater than? Let's say great or. Because if it's greater than, it's an or statement. So we're just going to think about, instead of saying greater, we're going to say great or. So that means that if it's absolute values isolated, it's going to be an or statement. So what I have is that x is going to compare to 7, or x is going to compare to -7. Now, next thing. I didn't change the sign, so I keep the inequality. But I did change this to negative, so guess what I do to the inequality? I'm going to flip it. So it almost follows that rule. If I multiply or divide by negative, I flip the inequality, because I'm taking that 7 that was to the right of 0, and I'm now flipping it to the -7, which everything reverses, so we flip the inequality. Guys, it's an or statement. So you determine if it's and or when it's isolated. So I'm going to remind you of that. Isolate the absolute value sign. Isolate what? Isolate absolute value. I got lost what I was doing. Then determine if it's and or. So I'm going to write in here great or. If it's greater, it's an or statement. So how do I graph this? Well, I'm going to ask you to pre-graph above to test it. Even if you think you know what's going to happen, let's test it. X is greater than or equal to 7 would be closed circle, shade to the right. X is less than or equal to -7, closed circle. Is this your typical or statement, one or the other? Yes. So it's greater than the big number, less than the small number. So that was my test to make sure it's not a special case or no solution. Again, I know some of you will fight me on testing it. If you can see in your head what's happening, that's fine. But a lot of errors on the test because we just graphed what we thought we should and we didn't actually test it. How would I write this in interval notation? Well, the low is -infinity, and where does it stop? -7 with a bracket, union, and it starts at 7 and it goes to +infinity. So inequality answer, interval notation, graph. We're looking for all of those ideas. All right, now this says the absolute value of x is less than or equal to 4, right? Less than looks like a smashed L. So instead of saying less than, guess what we're going to say? Less and. So the absolute value is isolated. So I'm going to go over here and add that. Less than is going to be called less and. And so now I'm going to compare x with 4 and x with what? -4. So we're using that skill. The absolute value of 4 and -4 gives me that outcome of 4. So with that idea, I didn't change anything, so I keep the sign. I did change it to the opposite, so I flip the inequality. So you might want to make a note about changing the inequality sign for the opposite answer. Got it? Now, an and statement. It's less than the big number, greater than the small, so it should overlap, but let's test it. X is less than or equal to 4. It's going to shade the whole way to the left. X is greater than or equal to -4. It's going to shade the whole way to the right. And so do we have that overlap? Yes. So if you collapsed your graphs, closed circle to closed circle was included, and we show this. All right. So I know it's an and statement, so I have to have overlap. What's really true, guys? If I pick any number in here or on the closed circle, it will make the statement true. If I pick something up here like 5, it's not going to be true. 5 is not less than or equal to 4. But 5 is greater than -4. So I always test in my top one. Interval notation, what's the low? -4. What's the high? 4. No infinity symbols, no variables, no inequalities in interval notation. Okay, now we haven't done any solving. Like, we're just talking about what happens. So here are the special cases. Okay, I'm giving you this x is greater than or equal to -3. Absolute value solved for. Is this an and or an or? Say it. Great or. So you don't get to pick. You don't pick what it looks like on the graph. The symbol tells you the absolute value is great or the -3. So it is going to be x compared to 3 or x compared to -3. All right, keep the inequality, flip the inequality. If we're not paying attention, answer looks good. And since it's an or statement, I'll get kids who will graph and go whoop and say they're done. So x is, oh, I didn't flip my sign. Hold on. Sorry. This was the same sign, and this is flipping the sign, right? I'm like, that doesn't work. Okay, see how this is a negative? Kept it the same, keep that the same. And what's the opposite of a -3? +3. I wasn't looking at the problem. Okay, fixed. Are we good? Okay. Now, before I go any further, some of you are looking saying, well, the absolute value can't be a negative. You're 100% right, but it's not equal to -3. What is it? It's greater than -3. Guys, won't every absolute value always be greater than -3? Like, the absolute value of 5 is 5. Is that greater than -3? Yeah, the absolute value of -20 is 20. Is that going to be greater than -3? Everything I take the absolute value of will be greater than a negative number. So my final answer here is all reals or -infinity to infinity. Okay, let's talk about why. Because every absolute value is greater than negative. If I did this on a number line, and I'm sorry I screwed up in the beginning, and I just throw this up on a number line, x is greater than or equal to -3 would do this. X is less than or equal to 3 would go left. And it looks like an and statement, but what did we say it was? We said it was an or statement. Or is one the other or what? Both. So how would you show this on a number line? You would shade the whole number line, drop the points, and then your final answer is negative to positive infinity. Okay, so where I screwed up was this should stay the same, and this one should have been the opposite, and I completely ignored that it was a -3 and just wrote down 3. Okay, now look at example B. Will the absolute value of x always be greater than -10? Yeah. Will it ever be equal to -10? No, that's no solution. Could the absolute value ever be less than -10? No. Okay, so the absolute value is isolated. And again, if you did this one, let me actually do this one right. We're going to compare x and -10. So since I didn't change anything, I keep the sign. Or we compare x and the opposite of -10, which ends up being what? Positive, and we flip the sign. Do you see that it's greater than the negative and less than the positive? So we're going to get that overlap. So again, if you graphed this one and you just did your little quick check, it is greater, open circle. It is less than, open circle, and one or the other. So even though that circle's open, it counts here, so it doesn't matter that it doesn't count there. So everything is shaded on the number line. The circles are dropped because they're overridden. And again, it's -infinity to infinity. So if you want to show that on your number line down here, you can. Both of these are going to be infinite solutions. Okay? All right, now look at the next special case here. This is isolated, agreed? So the absolute value, we said it's never going to happen. Didn't we say that? Like, can you ever have it less than -20? No. So both of these would be no solution. Now let's say you're in the middle of doing problems and it's not as obvious. And you're going through the motions. The motion is keep the -20, right? And then keep your sign. and, less and, keep your negative 20, and then it's the opposite of the answer, and flip your sign. How do I know this is not going to work? Graph it on a number line. I'm doing intervals of 20. Closed circle, x is less than goes left. Oh, closed circle, x is greater than goes right. Guys, this is an and statement. Is there any overlap? No. So this would be, these get thrown out. My final answer is no solution. So if you know that from the get-go, my absolute value will never be less than or equal to negative, you're good. But if you forget, do you see how the graph checks you if you're paying attention to the and the or? Okay, so let's get into really solving these. First, isolate the absolute value. Then determine less and, great, or. Do you see it down there? Solve both inequalities, graph your solutions, put your answer in interval notation. But the graph we're testing. Okay, so here we go. Number one, is it in focus? There it is. First, do we need to isolate anything? It's already done, agreed? What's inside the absolute value never changes. It's like a little armored car. You don't change the signs, you don't change anything. So I have what's inside 7 minus 4n compared to 27. Is it an and or an or statement? Which one? And, because this is less and. Okay, so I'm going to put the word and in here. So I kept it, so I keep the sign. I flipped it to a negative, which I don't think you could see, and I switched the sign. Okay, subtract 7. Negative 4n is less than or equal to positive 20. And hey guys, I'm dividing by a negative. What needs to happen? Flip your sign. Okay. Just going to write a little note. Flip sign. Okay. N is greater than or equal to negative 5. And subtract 7. Negative 4n is greater than or equal to, what was it, negative 34? Am I being smart or dumb? No, what am I doing? Yeah, negative 34. I'm dividing by a negative again. So n is less than or equal to, and then let's reduce our fraction. It's going to be what, 17 over 2? And what is 17 over 2 the same as? 8.5, if that helps our brains. Okay, before I say my answer, I don't want to just assume it works, so we're going to test it. Some of you know it's greater than the small, less than the big, so we know it's going to overlap. But for some of us, it's better just to throw it on the graph, see what happens. 8.5. And there's definite overlap that starts from negative 5 and stops at 8.5. Probably should start using a highlighter for my graphs. All right, what's your interval notation, guys? Low? All right, bracket negative 5, high? 8.5 and another bracket. All right, so your inequality answer has to have the word and in it, or you could write negative 5 is less than or equal to n. See, I'm reversing it, and n is less than or equal to 17 halves. You could write it sort of that compound way or with the word and. Okay, I think there were some mistakes in this idea yesterday on number 2. First of all, I can't get rid of that minus 1 because it's in the absolute value. I also couldn't get rid of it until I get rid of the 4. So I'm going to multiply by 4, so it cancels. And then I have to multiply this by 4. Some people are like dividing the other side. So I've got the absolute value of x minus 1 is greater than or equal to 8. Okay, I have the absolute value isolated. Agreed? So is it an and or an or statement? Say it. Great or. Great or. But you cannot determine that until it's isolated. All right, what's inside? X minus 1 is going to be compared to 8, or x minus 1 is going to be compared to negative 8. All right, so first one, keep the sign. When I flip the negative sign, flip your inequality. Add 1. x is greater than or equal to 9, or x is less than or equal to negative 7. All right, do you agree with me? It's an or statement, so we expect our graphs to split, but there could be a special case. So I am going to test my graphs out, close circle, and I'm happy with my answer, so I'm going to drop it on my number line to make it official. Again, some of you can sort of see this in your head, so you don't need to test it, but some of us just assume what it looks like, and then it's a special case. Here is my inequality. You cannot write this as a compound one like that. You have to leave it with the word or. Interval notation, you have two different ideas. The low interval, negative infinity to negative 7, bracket, union the high interval, 9 to infinity. Are we good there? Okay, number 3. What are you doing first? Before you can determine if it's and or. What do you need to do? Subtract the 3? Okay. So the absolute value of 8a plus 10 is less than 22? All right. So go ahead, and or. Less and, I agree. So set it up. 8a plus 10 is going to stay less than 22. And you said and 8a plus 10 is going to be greater than negative 22. So again, we're not changing what's inside. We're saying what's inside can be 22 or negative 22. All right, go ahead and solve. 8a is less than 12. Divide by 8. So a is less than, I'm just reducing by 4, guys, and I get 3/2. Sometimes when you're doing delta math, they don't want the decimals, so I leave the fraction, but 3/2 is the same as 1.5. All right, and has to be in your answer if you're going to keep them separate. Subtract. 8a is greater than negative 32. Divide by 8. And a is greater than negative 4. Are we good? Take a second, test your graph. Do we get any overlap? We're looking to make sure there's overlap. Well, it would start at 1.5 with an open circle, and it would go down, and it would start at negative 4, and it would go to the right. So I am happy with an overlap, open circle to open circle, and that means interval notation, parenthesis, negative 4 to 1.5. Good? All right, next problem, really similar. What's your first step in number 4? Subtract 16. Let me shut my door. Okay. Absolute value of 4x is going to be greater than negative 8. I didn't multiply or divide by negative, so I'm not flipping, and I just subtracted. Guys, I can tell you right now the answer. All reals. Why? Because the absolute value is greater than? It's always going to be greater than a negative. Okay. If you did the work, that's okay. I'm going to show the work real quick. You would have had 4x stays greater than negative 8, and it's an or statement, isn't it? Great or. 4x is less than a negative 8. So why am I doing this? Because I don't know that everyone would have caught the special case at the beginning, but I want to show you how you catch it at the end. So we would have got x is greater than negative 4, or divide by 4, x is less than 2. If I go to graph this, it'd be x is greater than negative 4, x is less than 2, and if I'm not paying attention, I might just shade between these two numbers. But it says or, one, the other, or both. So that would be my number line being fully enveloped and shaded here. And my interval notation, negative to positive infinity. So if you didn't catch that it was a special case at the beginning, do you see that you should catch it in your testing of the graph later? If you caught at the beginning right here, you could stop and go right to all real solutions. Okay? But your graph is your test. All right. Well, the mistake that a couple people were making was they were trying to distribute the absolute value. What's inside is grouped in parentheses, but the absolute value is not treated like parentheses. Nothing in, nothing out. So 3 minus k doesn't change. Do we get rid of the 9 or the minus 5 first? So we're going to add 5. Okay. So I have 9 times the absolute value of 3 minus k is greater than or equal to what? 63? All right, I still haven't isolated the absolute value yet, so I'm going to divide both sides by 9. And I've got 3 minus k is greater than or equal to 7. So here's what I have, and I'm going to do 3 minus k is greater than or equal to 7, and I said great or, right? And then 3 minus k is going to be less than or equal to negative 7. Are we good there? Okay, I'm going to subtract 3. So negative k is greater than or equal to 4. Can I have a negative k? Uh-oh, people are erasing. Did I do something or did you do something? Are we good? Okay, divide by negative 1, divide by negative 1. K is less than or equal to negative 4. Or subtract 3, negative k is less than or equal to negative 10. I'm going to divide by negative, so k is greater than or equal to 10. All right, it's an or statement. K is less than or equal to negative 4 would start here and go left. So it is a typical or statement. I'm happy with that. Drop it, make your graph official. A little hard to show that one, but we got it. Okay, go ahead and do your interval notation. Can you see it? Negative infinity to negative 4, bracket, union, bracket. There we go. Okay, we're almost there, guys. I'm having as much fun as you are. Okay, what am I doing first in number 6? And if you moved ahead, come back and make sure you did number 6 right. What's first? Divide by negative 4. Some of you are going to look at this and say, okay, greater, it's an or statement. It's not, because you have to isolate the absolute value first, right? You can't determine anything or break it apart until it's isolated, because we're saying the absolute value can be this. This is changing that. So divide by negative 4, divide by negative 4. It is going to be the absolute value of x plus 3 is what? Less than or equal to negative 2. Boom, I'm done. Why am I done? Will my absolute value ever be less than or equal to a negative? No. Okay, I'm not going to show it, but you get the idea. If you went through the motions because you didn't catch that, in the end, your graph, this would be an and statement, wouldn't it? In the end, your graph would do this, and that's never going to happen. So your graph should be blank, and you can do the no solution with the null set. You can say no solution, and there it is. So use your graph to test, isolate before you determine and or.